the logs. Excuse me. When we're dealing with properties of logarithms, there are basically three generic properties. Dealing with what are called product property, quotient property, and the power property. And what happens here is that if your logarithms have the exact same basis, you can pull things apart to expand them or condense them. For example, you have that log base b something times something is the same thing as the log base b of the first one plus the log base b of the other one. Those of you guys that walked in, I did collect all the different homeworks. There are 3 piles on my desk. You'll have to figure out which one goes where. So for a real simple, basic example of what this looks like, the first one, the log base b of multiplication, the product property. Let's say I have the log of base 3 of just 2x. 2x, it's showing that it is multiplication. So that means you can split it apart and rewrite it as log base 3 of 2 plus log base 3 of x. That's basically what that says. As you get into this, there are more and more reasons for being able to do this as we get into a lot of the actual solving of some of the equations. As we get into, we're going to be solving for x eventually into these logarithms, but I just want to get you guys into the properties themselves. The next one, quotient property, I'm just going to write them up on the whiteboard as well so we have them up in front of us. And it works the same way, it's just instead of addition, it's subtraction. So it's basically you take the log of the numerator, subtract the log of the denominator. Okay. Real simple example of something like that. Say we have log base 4 of, I don't know, x over y. Same thing as log base 4 of x minus the log base 4 of y. Now, as you see, what's going to happen here is you're going to be going this direction, and then you're also going to be going that direction, given those. So we'll be working both ways with these properties. Usually, what happens with a lot of us when we're doing these, it's not the ones that are difficult aren't the ones where, like 2 quick examples I have there. It's going to be the ones that have the combination of everything. That's usually where people start to make mistakes. And then lastly, the power property. Log base b of something raised to a power. Basically, all you do is you drop the power in front of the log. Same base. Whatever it is. Okay. So if it is log base 7 of x squared, in this case here, you've got that exponent. The exponent is 2. So when you rewrite that, it means the same thing as 2 times the log base 7 of x. That's basically what that says. Okay? I know you're going to put away your phone. Now, write something down too. That'd be helpful. I'm an ass. I've been gone for a week. I got a lot of time to make up for it. So, as you go through these things, as I said, we're going to be basically working on just expanding, condensing, using the different properties. So I'm going to give you guys a couple of quick examples of how this looks. I know the book likes to go through and give you approximations to use with subtraction and addition. I'd rather work on the actual back and forths of it. So let's look at this example here. Expand log base 2 of 7x cubed divided by 1. Assuming that x and y are all positive. They said that a lot of times because they don't want you to have to worry about your variables being negative, because you don't take logs of negative values. That's why they write that up. So the first thing you want to do when you see something like it's one of those weird-looking ones where you've got multiple things going on. Since there's division, you wanted to split it into the two problems right away. So you wind up with log base 2 of 7x cubed minus the log base 2 of y. Okay? All I did there was to split it apart right away with the division. Now, what else can I do? I got a power 1 and what else? There's a multiplication here, 7 times x cubed. So you split this guy apart as well. So when you go split that up, you get log base 2 of 7 plus the log base 2 of x cubed minus the log base 2 of y. And I heard you say it earlier, with this power 1, what's the last way to rewrite that? Yeah, put it in front of that log. So your final answer would just be log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. Now, a lot of times you guys are going to go, why do I need to even worry about doing all this? Well, back before this, before nowadays, you know, when this book was written, a lot of the calculators didn't have the change of base already built into them. Now, all of your calculators, you guys can press a couple of buttons and change your logarithmic bases from the standard base 10 to, you know, base 2, base 3, whatever you want it to be. Back, you know, it's only, you know, 8-10 years ago, calculators weren't able to do that. And since this book is about that old, it was still written in language that you had to be able to break these things apart in order to simplify some stuff. So you don't see it as often as you used to, but you do see this again a little bit into pre-calc as well, because they use this as well. But it's still, every once in a while I have seen expanding and condensing crop up on an ACT test. I think it has been in the prep books, so you will see a quick little expand or contract or condense logarithm. Question on that one at all? Which part? The whole thing again? All right. You see how we have this? We have the division bar right away. So whenever you see the division thing, all you want to do right off, once you see the division, just split it into the subtraction right off the bat. I'll give you a second. Once you split it into the division off here, there's nothing that you can simplify on this side, because it's just log base 2 of y. But when you come back over here, since you have 7 times x cubed, that means you can use the multiplication property and you can use the power property. So by splitting this apart into these two guys, because since it's multiplication 7 times x cubed, I make that a plus between them. And then since this guy is raised to a power, it comes over here. All right. So, and like I said, it's just practice because you've never seen it. It just takes a little bit of getting used to. It's like simplifying polynomials. It just took forever at first, but after a while, it got pretty easy.
So we're not going to be solving numbers, we're just going to be here.
It's not even an equation. It's just expanding. You could be expanding it or condensing it. And the condensing part is usually the part that's a little bit trickier. And we're getting it. We haven't thrown an equal sign in yet. We'll do that next week. Yeah, you'll be fine. For example, here's a condensing problem. Log of 6 plus 2 log of 2 minus log of 3. When you see that, what's the base? 10. Very good. It's a base 10 all across the board because there's nothing written there, so I know that it's going to be a base 10. Okay. We all agree on that? We also see that there's an addition symbol and a subtraction symbol, which means there's going to be multiplication and a division. And you also see a number in front of the word log. What does that tell you is going to happen? Exactly. So I know that since this right here has minus log 3, there's going to be a division, right? Okay. I know that there's a plus sign here, there's going to be multiplication up there. So we know that this is going to condense out to something of a log with a fraction. Do we agree? What goes in the denominator? 3. We okay on that? All right. In the numerator, I know it's 6 times what? 2 squared. Everybody agree with that? All right. What's 6 times 4? It's 24 divided by 3.
8.
There's 7% there. There's your answer. Yeah. You don't have to enter the actual decimal value. I really could care less what the decimal value of that is. If you went to your calculator right now and typed log 6 plus 2 log 2 minus log 3, it'll give you some decimal, which is the same the answer as log of 8, if you type it in correctly. Okay? But yeah, it works just the same. Okay? And like I said, one of the major reasons why we go through condensing and expanding these things was because back in the day you weren't able to do a lot of the things we can do now. So we just want to still give you guys the basics of why it works. Questions on that? It takes a little bit of getting used to. All right, I'm not going to lie to you. It's a little bit weird to start out with. Let's see. Yeah. Okay. These guys are all, I would like you to try and expand these 3. Can you see those okay? All right. I want you to try and expand these 3. Just write them a little larger. Log base 6 of 3x. Log base 2 of x over 5. And this is log of xy squared. Take a minute. These are all expand. All right? Expand those 3, please. All right, let's take a look. So hopefully, on the first one, log base 6 of 3 plus log base 6 of x. Do we agree?
Yes.
Okay. Log base 2 of x minus log base 2 of 5.
Yes.
Okay. Lastly, I'm just going to write this one down here out of the way. You get log of x plus 2 log of what? Come on, it's been a long week, ladies and gentlemen. What's that? Yes. Now, if you want to go ahead and jump, you know, I just what's the answer right away. If you wanted to split it and do that extra step, that's fine. If it helps you see it, if you see it right away, go for it. It's not a big deal, all right? And like I said, the expanding of these things is usually a little bit easier than the condensing, because sometimes when you're condensing them, you're not quite sure when to stop, all right? So let's try a couple of those again. Let's try some condensing.
Pause it while you guys are going through this part.
All right, let's check that first one. What'd you get? Log what? Do you agree on the first one? All right. 17, what'd you get? Log 5. Times 3. Ah!
Why can't you just write 3x squared plus 3?
Plus 3. Now, you could rewrite, that's fine, if you rewrite it as log base 5, because normally you would write it as 3x squared, because that's how normal people would write it. Remember, it's okay, if you wrote it like this, if you wrote it like that, that's fine. But remember, there's an addition sign here. Once you see the addition sign, remember, that means it's multiplying. One of the easy things to remember about this, guys, is remember, multiplication is just repeated addition. Okay? If you just remember that, just how you learned about that way back in the day as well. Okay? It all works the same. All right? 18 then. What'd you get on 18?
Log base 4 5x y.
Log base 4 or 5x y. Everybody agree? Very good. Very good. So, then on the last one. Whoa, wait. What is it? Now, careful. When it says 1/2 log of the x, what does that mean it's doing? This is the 1/2 power, not squared, it's 1/2 power. X to the 1/2 over.
Oh, I did that.
Or you could write it one other way. Remember, that means the same thing. 1/2 power means the same thing as the square root. So either way is fine. Okay? Either way is fine. Don't forget, whenever you see any number in front of the log, whatever that logarithm is looking at, log of 5, log of whatever this number is in front of log, this part is raised to that power. Okay? Every time. Now, here's that other little piece I was going to talk about today. It's called change of base formula. Now, like I said, a lot of times your calculators do this for you. Your calculators do this for you automatically now. So what I'm going to want you guys to be able to do, instead of just pressing buttons in your calculator, I want you guys just to write out what the change of base looks like. Okay? And it's a very simple formula. It won't take very long to go over. So a change of base basically means this. Whenever you're looking at log of base something of some number, log of base c of u. If that value of c is not a base 10, your standard logarithm, that means to switch it to a base 10 formula, which old calculators were only based upon, all you had to do was take the log of whatever over the log of the base. That's it. So if I wanted to figure out what the log base 3 of 7 is, instead of pressing all those buttons in my calculator, it's regular. Oh yeah, it's up a little bit higher there. Yeah, it's regular. I didn't mean to write it up that high up. How's that?
And then the bottom of it, is that regular C?
It is, regular C. Now, when I throw the number in here, you'll see how easy this is. So if I say log base 3 of 7, it's log of 7 over log of 3. That's all it is. Because like I said, 8-9 years ago, calculators didn't have that change of base formula built into them. So you had to have a way of being able to solve for simple logarithms. Not so much in advanced algebra probably, but some of the word problems you get from time to time would have to do that. But a lot of times in your pre-calc and calculus stuff, when you actually really use logarithms a lot more, you had to use change of base quite often to solve some problems. But nowadays, it's just so it's not that crazy. So, what I want you to remember is being able to rewrite logarithms using change of base. Just writing it out. Because I'll ask you, what's the equivalent of this, change the base to write the equivalency. Is that too difficult? Usually isn't. And it's also kind of nice dead giveaway, because isn't that 3 a little bit lower than the 7? So shouldn't the 3 go lower than the 7? It's a way to remember it, right? I just made that up. Mm-hmm. Not bad for guys only been eating carrots for 4 days. Gatorade. All right. All right, change the base on this one. What is it? Now, do you see why even though you guys can press buttons on your calculator to do that, you see how it is rather quick just to be able to do log of 7 divided by log of 5, and you can get the same results just as fast. That's all. I mean, I just want to know that you guys can know what change base formula is. And like I said, you're not going to use it a ton because your calculator does it for you automatically. It's just something that you should still see why it works. That's all. Let's see, I had a couple more, and now, you know, it's just, yeah, but think about this. A lot of these things, what I did here is just, these are a bunch of condensing ones, and I pulled out all the natural logs. That's all. I just got rid of all the natural log parts. You didn't have to do those. I think. I should probably double check, make sure there's no natural log. Because then on Monday, what we'll do is we'll jump right into the solving the equations. We'll solve equations on Monday. I'll be able to test out of this by Wednesday. It's about my best guess. Should be a big deal. We're a little bit behind, but it's not. Let's see, 17 through 29. Oh, you know what?
17 through 29 is that hard too.
Yeah, but you know what? I'm gonna change this a little bit. Sorry. I realize you guys don't need to worry about. Yeah, yes. So you can check your work, not just write down answers. I took out all the natural log stuff there. So in all honesty, it shouldn't be all that bad, guys. You should be able to fly through most of this. If you want to go ahead and get started now, you got a good 10 minutes. In all honesty, I think you should probably be able to finish it. Yeah, you're right. So, work. We will miss you terribly. We're going to start. Yeah, we'll get in.